Okay, so this video is on rational exponents and radicals. So first let's just remind ourselves what those words mean. So a radical is just the root symbol. So usually we look at it and we see that's a square root, but we can have other roots as well. In this little v, if I see a number like a 3 or a 5, that would be like a third root or a fifth root. But the radical is just this symbol. It means we're going to be taking the root of something. Remember, the word rational has this word ratio within it, okay? So a rational number is a ratio, and if it's a rational exponent, that means I'm going to have some base with an exponent that is a fraction, okay? So we're going to see how these two things are related. So m to the 1/5 power, this is telling me that m is being raised to the first power, but also we're taking the fifth root of it, okay? So both operations are happening at once. So in general, if I have a radical, the number underneath, which is actually called the radicand, but you don't need to know that. So I'm going to call this number down here, it's the base number. This is the number that stuff is happening to, okay? Then we have the radical over the top. In this little v, we may have an r, or a number, and right now I'm putting r there to stand for root. So this is kind of our root number. And then up here I might have a power, so this might be all raised to the power of p, okay? So that's raised to the power of p. Now, b is, again, our base number, so that's what stuff is happening to. So if you see this, if you have a radical, this number underneath, we're taking the r root of it and we're raising it to the p power. So both things are happening to it at once, right? So if I want it, this is called radical form because it has the radical here. If I want to write the exact same expression in what's called exponential form, so write this up as an exponent, then the base, the number that stuff is happening to, is going to still be the base in exponential form. The power is going to go on the top of our fraction, and the root is going to go on the bottom. So what this tells me is that my base is being raised to the power of p, and then also we're taking the r root of it. So both operations are happening to b, okay? So my first example here, if I have m to the 1/5 power, I can write this is in exponential form, right? I can change it to radical form by putting the base under the radical, putting the root in my little v, so that's going to be like a little smaller number, it's in the v, so it's different than having a number out here that's multiplied by it. And then my power here is a 1. So the 1 could go out here, it could go in here, or I could even write this as the fifth root of m raised to the power of 1. However, since my power is 1 in this case, I don't even need to write that power at all, right? So I could just write this as the fifth root of m, okay? So one thing that may help you remember what goes on the top and what goes on the bottom is this little saying, power on high. So the power it's being raised to goes on the top, and then roots down below. So think about a plant. The roots on a plant or a tree are down below the ground. So the root goes on the bottom here. Okay, so let's look at another example. So here we have n raised to the power of 5 divided by 6. So this means n has the fifth root and the fifth power and the sixth root. So if we put this in radical form, I'm going to have n down below, I'm going to have 6 here in the little v, and then I'm going to have 5 up here, okay? So that is going to be the exact same expression. They're going to be completely equal to each other, just two different ways to write the same thing. Okay, let's try another one. So on this one, I have 10x in parentheses, so my base is 10 times x. It's being raised to the fifth power, and we're taking the square root. So I could write this as the square root of 10x raised to the power of 5. Now notice here I didn't put a number here. That's because this is a square root. Anytime we see a radical, we automatically think square root. The only time it's not a square root is if the number here is different than 2. So if there is no number here in the v, that means it's a square root. And so I could write that as a 2 if I'm going back the other way, if I'm starting in radical form and going to exponential form. So one thing to be careful of here is if I'm, in this case, if I were to write the 5 underneath with x like this, I have to be really careful with that, because now this does not mean the same thing as this, because in this one, 10 and x are being raised to the 5th power and are having the square root taken of them. In this one, the only thing being raised to the 5th power is x. So 10 is not being raised to the 5th power if I write it like this. Now I can correct that just by putting parentheses around or by putting that power on the outside. But just be aware of that and be thinking about that. If I write something like 5x to the 3rd, the only thing the exponent is on is always the variable or the number right next to it. It will not include the one in front of it unless we put parentheses. So that's the one thing to kind of watch out for on these. All right, let's skip ahead a little bit and try something else. So on this one, I see that there's just a p under a radical. There's no numbers around it. There's no power, and there's no root. So remember, if there's no number here, that means this is a square root. And if there's no power here, that means it's being raised to the 1st power. So before we were going from exponential form to radical form, now we're going from radical form to exponential form. So this would just be equal to p over 1/2. Again, if I don't see a number in the v, it's a 2. If I don't see a number on this side, it's a 1. Okay, so that would just be p to the 1/2 power. All right, let's try another one. So here we have m underneath. We've got 3 and a 4. So remember, power on high and root down below. The root is always here in the v. So this would be m to the 4/3. Okay, now here we have 10x underneath, and we have a root of 5 and a power of 6. So again, be really careful here because we have 10 times x. So we have the power of 6 and the root of 5 here. But if I just write it like this with 10x to the 6/5, that 6/5 power is only on x. It's not going to include the 10. So we have to correct that by putting parentheses around this so that all of the stuff under here, all the stuff that was the base, is getting the operation power of 6, root of 5. Okay. All right, so let's go ahead and try another one. So now I'm going to have 4x squared underneath. So notice here that this squared is only on x. There's no parentheses around the 4 and the x. So that means this squared here is only on x. So the power that's on the entire thing, on 4x squared, would just be a 1. So if I were going to write this one, I want 4x squared as my base. I need to put parentheses around that, and then my power is 1 and my root is 3. Since there's no parentheses here, that means 4 is not squared, only x is, so I have to write it that way here too. Okay, so just be careful with that. All right, so now we're going to shift gears just a bit, and we're going to do the second part of what we need to do. So now our instructions have changed, and it's asking us to simplify. So we're going to be simplifying square roots. I know your calculator will do this, but that's not what we are going for here. I want you to understand what's happening when a square root gets simplified. So first of all, let's start with one that is a perfect square. So for example, the square root of 25. Now we all know that the square root of 25 equals 5, and that is because 25 is equal to 5 times 5, right? So what a square root is asking you is it's asking you to find a number that when you multiply it by itself, it gives you this number that's under the square root. So if I have 2 5s multiplied together underneath, that means the answer, or it is equal to just one of the 5s, right? So we're going to apply the same principle to a square root that's not a perfect square. So 512 is not a perfect square. but I can still simplify the parts out that are perfect squares, and in order to do that I need to find them. So what we're going to do is we're going to make a little factor tree. We're going to find two numbers that multiply to 512. It doesn't matter what the two numbers are. There's many ways to multiply to 512. So we just need to start out by finding any one that will work. So since this is an even number, I'm just going to go ahead and divide it by 2. So 256, I believe, would be half of 512. So I'm going to circle the 2 because 2 is a prime number, but I'm not going to circle 256 because I know I can break that down a lot more. So every time you hit a prime number, circle it. Remember, a prime number is a number that can't be broken down anymore. The only two numbers that multiply to 2 are 2 and 1. And so I don't want to go past that number. I don't want to go down to 1. So circle if it's prime. If it's not prime, keep going. So 256 is also even, so I'm going to divide it by 2. And that would give me 128. And then again, it's even, so I'm going to divide it by 2, and that would give me 64. Now I know that 64 is 8 times 8, but those again aren't prime, so I'm going to keep going. 8 is 2 times 4, and 4 is 2 times 2. So this number is just made up of a whole bunch of 2's. Whoops, 2 times 4, and 2 times 2. So now what we've done is we've broken 512 down to all of its prime factors. So if I were to multiply all of these little 2's that are circled back together, I would get 512. Notice I didn't circle any number that wasn't prime. Those aren't the ones I'm looking at. So now, just like when I was doing square root of 25, if I have 2 underneath that are multiplied together, they're the same number, I can pull that number out of that square root. So that's what I'm looking for. I'm looking for pairs. So anytime I have a pair of 2's, I'm going to pull one out. So for these 2, I can bring one out. For these 2, I can bring one out. And I'm just going to multiply them back together once they come out. For these 2, I can pull one out. For these 2, I can pull one out. Okay? Now notice, there are 8 2's in here, right? But I only pulled out 4 of them. I have to pull out 1 for every 2 inside. Just like when I take the square root of 25, I only pull out 5, even though there's 2 underneath the square root. Okay? So I'm undoing those square roots by taking 1 out. Now this 2 right here is alone. There's no other 2 to go with it, so that one can't come out. That one's got to stay underneath, because that's the part that's not a perfect square. So now I'm just going to go ahead and multiply these together. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So the simplified version of the square root of 512 is 16 square roots of 2. Now again, I know your calculator would do this, but please don't use your calculator. Make a little factor tree. I need to see your work on these in order to give you credit for them. Okay? This is to help you understand what's happening when we do a square root. Okay? Okay, so let's try another one. So now 36 is actually a perfect square. 6 times 6 equals 36. So we could actually just write this down right now. It's equal to 6. But let's hurry and go through it. So 36 is 3 times 12, or I could say 6 times 6 and break those down. 3 is prime. 12 is 3 times 4, and 4 is 2 times 2. So if you notice under this one, I have 2 3's, so I'd bring out a 3. I have 2 2's, so I would bring out a 2, and then no numbers are left. So if no numbers are left, that means my square root is going to go away. Okay, or basically it's like the square root of 1, which is just 1. So 3 times 2 equals 6. So if everything comes out, that just means it was a perfect square, and the square root would disappear. Okay? Alright, let's try one that has a variable in it. So like this one. I've got 32x to the third. Now if you have variables in there, the first thing I want you to do is ignore them. Just ignore them for a moment and just concentrate on the 32. So we're going to break down 32. 32 is 2 times 16. 16 is 2 times 8. And 8 is 2 times 4. And 4 is 2 times 2. So I'm looking for pairs. I have 2 2's there, so that'll bring 1 out. I have 2 2's here, that'll bring a second 2 out. And then this 2 stays underneath. So outside I have 4, inside I have 2. Now if I look at my variables, x to the third power, that means x times x times x. So again, x is the same number all 3 times, so that means this is the same number times the same number, so it's also a pair, right? Just like the others. So if I have 2 x's outside, or inside, I can bring 1 outside. That one doesn't have a partner, it can't get out, it has to stay underneath with 2. So this would simplify to 4x on the outside and 2x on the inside. Alright guys, so give it a try on the homework, and I hope you have a lovely day.